Looks like we got Algebra 2, Lecture 5.2 through 5.5, State Standard OAS A2N13. Student will identify the dimensions of a matrix, add and subtract matrices. Matrices is the plural of matrix, so you'll hear me say matrices when I'm talking about more than one matrix. The student will identify the dimensions of a matrix, add and subtract matrices if possible, determine whether the sum or difference of matrices is defined, and multiply by a scalar. That's what we're going to try to do today. And first of all, we want to talk about what is a matrix. So let's take a look at that. A matrix is a rectangular array of numbers, and they're in brackets. And they're arranged in rows and columns. And here's an example of a matrix right here. An array of numbers arranged in rows and columns. We call this matrix A. Each number in a matrix is called an element of the matrix. So this is an element of the matrix, that's an element of the matrix, so forth and so on. In matrix A, that's this matrix, element 1, 2 is in row 1. So here's row 1, row 2. It's in row 1, column 2, column 2. Rows go this way. Columns go like the columns of a building. They go straight up and down. So row 1, column 2 is 4. All right. The dimensions of a matrix are stated as the number of rows by the number of columns. So there are 2 rows, there are 3 columns, so this would be a 2 by 3 matrix. That's what this says right here. The dimensions of matrix A are 2 by 3, which reads, this 2x3 reads 2 by 3. That's how you say it. So it's a 2 by 3 matrix, array of numbers and an array of numbers in brackets. There we go. That's a matrix. Adding and subtracting matrices. Matrices can be added or subtracted only if they have the same dimensions. So this matrix right here could only be added to another 2 by 3. Alrighty? Adding and subtracting matrices. Matrices can be added or subtracted only if they have the same dimensions. If they have the same dimensions, we add or subtract corresponding elements. And I'll show you how that works here in just a second. A scalar is a real number that's multiplied by every element of a matrix. So we just take a number, multiply it by every single element, and that number is what we call a scalar. There we go. So here's some examples of what we're talking about up above. I'll run through them very quickly, and hopefully it'll make sense. We're going to add this matrix to this matrix, or we're going to try to. We're going to see if we can by seeing if the number of rows is the same, which they are, and the number of columns. So I have 3 rows by 2 columns, 3 rows by 2 columns. I have the same dimensions, so I can add the matrices. We add matrices by adding corresponding elements. 2 plus -3 is -1. 5 plus 5 is 10. Hopefully I can do arithmetic correctly. -4 plus -5 is -9. 6 plus -2 is 4. -4 plus -5 is -9. And -6 plus 2 is -4. We have added these 2 matrices. Now remember, the dimensions are 2 by 3 if they have 2 rows and 3 columns. The dimensions of this are 3 by 2, rows by columns. So if we start with a 3 by 2 and we add a 3 by 2, we're going to get a 3 by 2. Good. Looking at this one, I have a 3 by 3, rows by columns. Okay, 3 rows by 3 columns. Plus, I have a number here that's outside this matrix. That's a scalar. So what we're going to do is multiply every single element in this matrix by this scalar, and then add the resulting matrices. This one's going to remain the same. -5, 0, 3, 6, -2, 0, -2, -4, 6. Hopefully I copied that correctly. Plus, now I'm going to take this scalar and multiply it by every element here. That's -16, 24, 12, -24. Hope I'm doing my arithmetic correctly. +24. Another 24. Lots of 24s in this matrix. 20, 8 and 8. So we have multiplied the second 3 by 3 matrix by a scalar, and now we're going to perform this operation. The operation is addition. If it was subtraction, we would go -5 minus -16. We have to watch out for double negatives and such, just like we did when we were adding and subtracting integers. That's essentially what we're doing here. So we're going to wind up with, we add a 3 by 3 to a 3 by 3, we're going to wind up with a 3 by 3. So here we go, -5 plus -16 is -21. 0 plus 24 is 24. 3 plus 12 is 15. 6 plus -24 is -18. Do my arithmetic correctly. -2 plus 24 is 22. 0 plus 24 is 24. And -2 plus 20 is 18. -4 plus 8 is 4. And 6 plus 8 is 14. If I haven't made any arithmetic mistakes, we performed these operations. We saw that we were multiplying this matrix by a scalar, 4 in this case. We did that. I'll check my arithmetic real quick. -16, 24, 12, -24, 24, 24, 20, 8, and 8. And then, once we multiplied by the scalar, we perform the operation addition, adding corresponding elements. So -5 plus -16 is -21. I'm going to double check this. It'll be 24 minus 6 is 18, so that'd be -18. -2 plus 20 is 18, so forth and so on. 24 plus 22, yes, 0, 4, so far so good, yay! 15, wow, I got lost. 0 plus 24 is 24, and 6 plus 8 is 14, yay! So there we go, that's how we perform operations, the operations we're going to do today. Scalar multiplication and addition of matrices. Let's take a look at one more. Here we go, we are asked to add these matrices. I see that it's rows by columns, 3 by 3, and I'm going to add it to a 3 by 2. I can't do that. Undefined. They have to be the same dimensions. So if you are asked to add two matrices and you see that they're not the same dimension, this is what you look for in a multiple choice scenario. One of your choices should be undefined. And that's what we're doing today. Addition, subtraction of matrices, and a little bit of scalar multiplication. You can do this.